Good evening, everybody. So, the topic of my presentation today is SDN is a promise for better network monetization for service providers. And from service providers' perspective, I think it's the key element. It's the most important thing that they are trying to achieve with SDN. So I'm going to touch upon why carriers, service providers are interested in SDN. What are the drivers? What SDN would really deliver for them? How would it all happen? And what are the challenges? And what are some solutions in the making? So a famous heavy reading graph here, which shows how the traffic is increasing, but not the revenue. So service providers need to better monetize their network. SDN is going to transform how networks are built and operated today, how services are created and monetized today. But service providers are under a lot of pressure to control cost while building and scaling and operating their networks, and introducing new services in their networks, and provisioning and all the time that it takes in order to onboard a new service, which is really a long time, and which means lost revenue for them. So they are very pressed to find solutions which can help them monetize their network better. And so these are the pressing issues that service providers are facing. And despite all the transformative technologies like Ethernet and WDM, which offers very high performance at much lower cost, has not been able to really translate into increase in revenue for service providers. So, customers demand more bandwidth, but they are not willing to pay higher price. So it has been seen that customers subscribe to Ethernet services, for instance, with the expectation that they would have much higher bandwidth available to them. But their expectation is that it would be at the same price point that they were paying for the legacy networks. So that does not translate in increase in revenue for service providers. So what are the service provider challenges? So control cost, scale capacity, and innovate. So control cost, as I said before, cost per bit has a CapEx component and an OpEx component. For CapEx component, what has been happening, that service providers has been pressing network vendors, infrastructure vendors to reduce prices. And even the most aggressive service providers understand that in order to have a stable ecosystem, that's not a sustainable model. So then the OpEx. So current networks are not built with OpEx in mind. Network vendor interoperability and technology interoperability is non-existent, which does not translate to OpEx efficiency of the network. And both suppliers and the service providers did not have that as at the top of their agenda back then. So it is important that efficiencies in OpEx is also introduced into the network. So when it comes to scaling capacity, there's a huge increase in data traffic from residential, business Ethernet, and mobile data. There's an increase in data. But what is happening is that increase in data, meaning that service providers have to scale their capacity as well, which is not happening, right? And according to a Cisco survey, IP traffic will grow at a CAGR of 23% from 2012 to 2017. There's a huge growth, and annual global IP traffic will surpass zettabyte threshold. This is huge, huge growth in data that we are seeing. So not only it is hard for service providers to keep scaling their bandwidth, there's also the problem that even when there is available capacity on their circuits, it is hard or impossible in today's networking environment to orchestrate that extra bandwidth to be used for another customer. It is not possible in today's static networks. So this is a huge problem. They cannot keep on over-provisioning their networks. So they have to find better way to utilize the available bandwidth that they have in the network and also how to scale the bandwidth. And when it comes to innovation, right, it takes service providers a long time to roll out new services, to provision new services. It involves not only updating the routers and switches in the network, but it also about updating the back-end systems. OSS, BSS, and NOS systems need to be updated as well. So that, again, is a hindrance, a roadblock to innovation. So these are really all the challenges that are driving service providers' interest in SDN. So what SDN is promising to service provider? So SDN is promising CapEx and OpEx savings, right? Operational simplification, service innovation, single orchestration touchpoint, and business intelligence. So operational simplification with the data layer and the control layer being abstracted from each other, and the control layer being vendor independent, gives service provider a lot of operational simplification in their network. And also, because it is not anymore vendor specific, they can scale their networks much more easily. Service innovation can be twofold. Not only it will open up the network for service providers to write new applications within their network, but it would also open up a third-party application development ecosystem where third-party developers would write these applications to be used by service providers in their network. A single orchestration touch point. So all these services will come on board through a single orchestration touch point. They will be managed by this single orchestration touch point. So it would really facilitate and accelerate the time it takes for service providers to introduce new services and customize those services for their customers. Then business intelligence. Now, business intelligence is also one of the promises that SDN has for service providers. One example of business intelligence can be that a business analytics engine can evaluate the network for the traffic peaks and supply and demand curves in the network. And it really raised the network cost database of function when the traffic is at its peak, and when there's a glut, it can lower that network cost function. So that is an example of business intelligence and how it can translate into more revenue and generating new revenue streams for service providers. For example, a small enterprise which is subscribing to much lower bandwidth, but if the higher bandwidth comes at a lower price, they can subscribe to that higher bandwidth and provide a means to make some more money for service providers. So how would it all happen? What are the different architectures? What are the different models for this SDN? So here you have the Open Network Foundation architecture as presented by ONF. So there are 3-4 key elements of this architecture. One is, of course, the abstraction of control and the data layer, forwarding layer, and also the direct programmability of this control layer, right? So that is very important. And then standardization of interfaces between the control layer and the data link layer and the forwarding layer. So that's another key element of the SDN architecture. So what are the different models that we are looking at right now? One is hybrid distributed model. Another one is standard centralized model. Hybrid distributed model is all about what we already have in the networks today. The routing and switching infrastructure that we have in the network, it all have a control plane, a routing operating system, and routing systems embedded in the hardware, in the infrastructure that we have. So distributed model or the hybrid model leverage that control plane in order to provide an abstracted, virtualized control plane from that network infrastructure that we already have, and then present that layer of network services and to higher layer or the application layer. So this is the hybrid distributed SDN model. The key point here is that it is not open flow based. It is what we already have in the network, and also the important thing is that we can leverage the existing infrastructure and still can provide SDN-like applications and services and means to monetize the network through this distributed architecture. Then we have centralized or standard SDN model. This standard model is really based on ONF model, right? So it is based on OpenFlow, which is the de facto SDN standard used today. And when it comes to OpenFlow, there's good news and bad news. The good news is that almost all major routing and switching vendors have OpenFlow on their roadmap. They have already have some version of OpenFlow. There are multiple versions of OpenFlow available, or it is on their roadmap. The bad news is that OpenFlow is not a mature standard. It is just in the process of being standardized and written. First of all, it does not provide any service control software, which is key to an SDN architecture. That is missing. Off-config, which is OpenFlow configuration protocol, network management and configuration protocol, that also is not fully defined as of yet. It is still in the process of being defined by ONF. Another thing is that right now, OpenFlow does not support non-packet flows or wavelength flows. Although there is a recent ONF charter on optical transport working group, which is trying to solve this problem and define the protocol and standard for optical layer. Then we have northbound API. ONF does not support an open standard northbound API, and it has not even promised anything on that front as yet. So these are very key elements that are missing from a centralized standard SDN model. And unless we have solutions for all these things, we cannot realize this SDN dream. So how it's gonna happen, what would be the path from evolution to revolution? So current networks are really connectivity centric. We have static networks, which are really proprietary, vendor-specific networks, closed equipment grouping, and hardwired. And these are evolving into service-centric networks. Service-centric networks are all about delivering automated dynamic services to customers. So this is something very important for service providers because they are looking for ways to deliver those dynamic services to their customers. But the key thing is these service-centric networks are going to be multi-vendor and multi-technology. That's why the SDN type controllers that we have in the marketplace, they are working diligently to have more and more vendors on board so their SDN platform can work with maximum number of vendors, right? Because these SDN controllers, which are sitting in the yellow portion of the pyramid here, are really working on the distributed model or hybrid model, meaning they are going to talk to the firmware of these network devices that we already have. And in order to do that, they need to talk to the vendor and have that interoperability sort of scheme with them in order to realize that. So then, what is the future? Future is application-driven networks, right? The future is when the applications would really determine how the networks are going to behave. So the nature of networking would evolve from providing the connectivity to supporting applications. So that's the bottom line. And which is a paradigm shift, actually, in how we are doing networking today. So what would be the tentative timeline? So in the next 2 years, we would see a lot of service delivery automation type platforms that would be introduced. And these service delivery platforms would really make it easy for service providers to deliver those dynamic on-demand services and create new revenue streams for them. Then we would move on to true network virtualization with the control plane completely decoupled from the forwarding plane and have a global view of the network in a logically centralized way and being able to be programmed directly. Those networks are going to happen when we have found the solutions to some of the challenges that we are facing right now. And that is the next thing that I want to talk about, the challenges that lie ahead. So it's all very good to talk about all these promises, but those promises are not going to be delivered until some of the solutions are found. One thing I've already sort of touched upon, which is OpenFlow is just maturing. And we have, I have talked about ONF, Optical Transport Working Group, and off-config and ONF northbound API, and also the service control software. All those protocols need to be specified before OpenFlow can be a true de facto SDN standard. Without that, it is not possible. Overall, service control software is missing. Service controls, what is service control software? Service control software gives the ability to find routes through the network and really discover the networking state, the network state. And that is not available right now. But there are solutions. IETF has interface to routing system. That interface to routing system provides a deeper intelligence into the routing operating system and routing systems that we have today. So for SDN to work, applications need a more sort of intimate relationship with the routing system, which we do not have today. Internet to routing system provides that kind of interface with the routing system in order to build the routes through the network, extract the topology from the network, and all of those things, and discover the network state and operational sort of parameters for the network. So then the lack of open standard for northbound API. So without this northbound API, the innovation ecosystem that we have been talking about is not going to possible. SDN definition of application is very broad, right? It has many applications from network services side, load balancing, and QoS, and network virtualization applications, and business application, unified communication, and all of these different applications. Now, these applications speak different language with the network, and they have different interfaces with the network. But in SDN world, it cannot happen that way if we want to innovate network services. It has to be a standardized, open interface through which applications can talk to the control layer and to the infrastructure layer. So Open Daylight is a consortium of network vendors and SDN vendors, and they have an open source SDN controller framework which defines an open framework for northbound applications. So that is some work that's going on. And then also ONF northbound API. So there are some discussions in ONF as well to work on northbound API, an open standardized northbound API. Then the next problem really which needs to be resolved is managing control traffic in centralized network. So all this service control software that we need in order to extract all this topology information and really detailed topology information from the network, to extract all this routing information from the network state information, and all the telemetry traffic from the network probes to collect that network state. All of this would translate in a lot of control traffic on the network. Some of this network telemetry can introduce more traffic on the network than the application itself. So the more control traffic than the application traffic. And also the distributed applications, they put a lot of traffic on the network without really optimizing the path that these applications should take through the network. So all of this is contributing to a lot of traffic on the network. Now we have application layer traffic optimization protocol that it kind of finds the best route through the network for these applications and optimize the traffic through the network. But what is missing with alto kind of protocol is how do we distribute this information across different IGP domains? How do we distribute this information across different autonomous systems, for example? Because that needs a means to go into the traffic engineering databases of different IGP domain and link state databases of a different IGP domain. And there are no standards available to do that. I can read the TED server from my IGP domain, but not from another IGP domain. So IETF has introduced this protocol called BGP-TE-LS, Network Layer Reachability Information, NLRI, which makes it possible in a standardized way to collect that information in order to provide better traffic engineering options, in order to provide better paths through the network for these applications, so that we do not have any traffic, any control traffic on the network which is not really needed on the network. Another thing, and I would be very, very quick with that, boundary functions are needed. So when these SDN, so service providers and enterprises are not going to deploy SDN end-to-end in their global networks. They would introduce SDN domains in their existing legacy networks, IP networks, or maybe TDM networks. And there is a need that this SDN enclave should be able to talk to this IP network and give it all the discovery and reachability information and extract that information from the IP network. So this is important. Otherwise, how would these enclaves would work within an IP network or in a legacy network? And also, these SDN domains would need to communicate amongst each other. And IETF has tried to solve that issue by introducing this protocol called SDNI, which is SDN Interface Protocol, which gives all the coordination of flows, traffic flows among the SDN domains, and also the reachability information among the SDN domains. So on that level, it has been tackled by IETF. But on interconnection or interfacing with the legacy network, with the IP network, PCE architecture is there. And PCE architecture is one of the distributed architecture or hybrid architecture that we talked about. But again, PCE architecture does not give us a means to go into another autonomous system and read the routes from there and create end-to-end traffic engineering paths in a network. So again, NLRI, which is a new protocol by IETF, can help solve that problem. So I think we have a few minutes for questions and answers.